hello everyone. Welcome to this session of Boost Your Angular app. And in today's sessions, we are going to look into the basic steps like how can we improve the our application performance in Angular, and we will look into the some metrics like why they matters not in the Angular in every application those metrics are matters, and like how can we improve the those metrics in our applications, right? So like this is on Angular, so we will look into the how can we improve with the Angular. So it's presented by me, Piyush Agrawal, and the Arjun Pandit. So starting with the knowledge etiquettes. So please be punctual. So we should join the session 5 minutes before the starting, so we can calculate time. Please provide the constructive feedback to us, so we will understand, like we will improve ourselves, and we will come with the such more content, more such content. And please make sure your mobile phones are on silent mode and avoid disturbance like chit chat during the session, right? Starting with the agenda. So today's agenda is like introduction, like I already give the introduction, but we are going to do in session, right? But we are going to learn, right? Next we'll learn the why performance optimization matter. Then we look into the Angular specific strategies, like an on push strategy. Then we look into the lazy loading, why this matter and how can we implement lazy loading. Then we look into the standalone component and why they are like good for us. Then we look into the how can we optimize the our component, right? Component level optimizations. And then we look into the asynchronous operation optimizations, like when are we calling the API. So how can we improve the handling, right? Then we look into the Webcore vitals, what are they and why they matters for every application, either you are a Java developer, your React developer, Vue.js developer, Svelte developer, Angular developer, doesn't matter. These Webcore vital matter for every applications. So we will look into them. Then last we have a demo. Okay. So starting with the introduction. So as I explained, we will look into the how can we improve the performance of Angular application. We will look at the best practice techniques we will going to use. Then we look into the pros and cons of every approach, right? Next is the why performance optimization matter. So anyone can explain like why performance matter? Okay, I'm taking it as a no. So as a day to day, right? Like we are going any site or we are using any application, right? As soon as we are presented with the content or data, like we feel that this application is really well, like as you are going to order the food on Zomato, right? And you just open the application, and then the list of the food is available to you, right? Now you are satisfied. Now you can select the food that you want to order, right? So it's not like it's saving the time, right? And so like if you're taking the 1 minute to load the data, then you are not going to stay on the application. You will move to another application, right? Why should you be is there any another application that providing the fast loading with the food, right? So you will go to that application, right? So it increase the user experience, reduce the load time. So if you are implementing the optimizations and following the best practice, then the application will load fast. And if your application load fast, right, the user will stay on your application, right? User will not close the application and move to another application, right? So it's like basically retaining the user. And like it's cost metric, right? So if the user return, that it will order the food with our application, right? Now to the scalability, let's assume we are ordering the food, right? And there is a lakhs of users who ordering the food at the same time, right? So if we optimize our application, right, by UI y API, right? So the all the users have the same response within the minute they are able to order the food, right? And there is no any slowdown, crash of the system, right? System will be working as and smoothly, right? So this is the optimizations improve the scalability of application. So this is the why the performance optimization matter in every application. First, for user experience, reduce the load time, retaining the user, scalability, right? Now, next we look into the how can we improve the performance in Angular. So in Angular provides the some strategies, so we can follow the strategies to optimize the applications like in day-to-day work, right? we are creating the routing, right? We are like creating the components, right, in Angular day to day. So we can use that approach and optimize the application. So anyone have any question till now? Okay, I'm taking it as a no. Okay, moving to next. So the first one is using the on-put chain detection strategy. So by default, Angular comes with the two strategies. That is the default, and the second is the on-push. In the default, whenever any asynchronous operation is going to execute, right, or any operation is going to execute, right, so template rendered, checks is going to execute, and the UI is updating, right. All this happen at an instantly, right. But when we have a dependency, let's assume we have some APIs and depend upon the another API response, right? At that time, what will happen? The template is rendering every time whenever the new variable value is updating. But we can limit the checks by using the on push chain detection strategy. We can tell the Angular now we have a control. You don't need to re-render the template, and when we have a data, when we tell you now update the view, then it will going to update the view. Why we are like controlling this like updation, right? Why we are controlling? Because it's time consuming or re-rendering on DOM, and it's memory consumption. Basically it take memory, and every time DOM updates, it's not good for us, right? So make sure that DOM will not update every time. We should use the on-push strategy that help us to improve the performance. And now, like how it work, the study focus only on change in the input properties or event, reducing the number of checks Angular has to perform, right? So let's assume we are using the adder input variable to get some property from the parent data. So it will only detect the reference change, right? So make sure if you are using the on-put chain detection strategy, then you should understand what you are doing, right? And like what is the result? If we talk about the result, that it improving the performance, reducing the load time, reducing the unnecessary checks, right? And also like unnecessary DOM is not going to update it, right, every time. Resource is also going to be optimized. But what we need to make sure when we using that one, required careful handling of input binding. So if you are using at that input, as I explained, right, so it detect only the reference change, right? So let's assume you are using the array and you are updating only specific indexing data, right? Then it will not going to be it will not going to detect the changes. You need to update the new reference, right? Then it will going to detect the changes, update the view. Okay, now in the cons can cause issue if change occur outside the Angular detection scope. So let's assume in Angular provide the functionality of running the code outside the Angular zone, right? And if you're running the code outside the zone, that it will not detect the update. It will not detect the changes and will not update the view. Now, as I explained, it's required a deeper understanding. If like it's like depending upon the how we are handling the component, and exceeds using of the on push may cause the unexpected behavior. So make sure if you are using the on push, then you should aware that what are you doing and how it's going to affect your component, right? Anyone have any question? For the demo, we are going to look into the demo, like how can we use that one and how it's improving the performance. Okay, anyone have a question? Okay, I'm taking as a no. Next is the lazy loading the modules. So like in the every application, like we come with the approach of creating the splitting the code, right? Split the code, right? So in Angular come with the module strategy. Like in the new version of Angular, it's come with the standalone component, right? But in the older version, like Angular 14, 16, 15, 13, 12, Angular is the working on the module basis. So in the module basis, module is a, if I define the module, it's a combination of the directives, components, right? So multiple components are in the one module, right? So it's like a single chunk behind multiple modules. We can get multiple modules, right? And on requirement we are loading the specific module. So let's assume we are an admin module, we have a user module, right? Then when user is visiting to us, then we are only loading the user module. When admin visiting to us, right, our application, then we are only loading the admin module, right? So it's like basically helping us to improve the performance, right? Unnecessary code is not going to be load, unnecessary file is not going to be load from the server, right? Like whenever a large application we have, multiple modules, then we can use the lazy load for the improving performance. It's reduce the initial load time as we split the code, right, in the multiple chunks. So the specific path module is going to be load at a time. Then it's really like we are unnecessary files are not loading, right? So improve the load time. Optimize performance of large applications. Yes, like if we are loading the specific module, then the it easily improving the performance, right? Improve user experience. So like if we have now slow bandwidth, slow network, right? Then and we are loading the only the few chunk of data, like 1 KB of data, that it's easily downloaded from the server, right? So it's improve the performance, user experience also. Cones, in term of cones, add complexity to routing configuration. So yeah, you need to add a load children. If you are using the resolver, then make sure that resolve how is resolver going to behave, and API, like resolver is the basic thing. Like sometimes we use resolver to load the data, right? We have the data, then we are loading the path, right? If you are using that one, then it will load the module after getting the data, so it reduce the performance, right? Require proper testing to avoid load time issue. So make sure if you are uh, using the lazy load strategy, right, then the modules should not be added inside the another module, right? If you are defining the module in another module, then it's not then lazy load, it will load the module within the time when the specific module is loaded, right? So in term of example, let's say we have an admin module and user module, right? And what happened, like you by mistakenly added the admin module inside the user module, right? Now when user is visiting to our site, right, so what happened, like you when user hitting the URL, the both module are loaded at a time. That's cause an performance issue, right? So we should make sure that if we are creating the lazy load, we are loading the module lazily, then it should be separately defined, right? They are not linked to each other. Now any question, anyone? Okay, I'm taking it as a no. So next is the standalone component. Standalone component basically the we can say is a single piece of code, and where we have independent dependencies, independent, all the things are independently, right? And we are able to load that component on our requirement, right? So Angular comes with the this approach in Angular 18. In Angular 18, still was a standalone component introduced, and we can simply, if we need to load the component lazily, previously we are loading the component inside the module, right? Now we can directly load the component by lazily using the load component, right? And it will improve the performance, because if we have a specific data, let's assume we have a header. The header is a standalone component that not depend upon the other component. Now we need to load the header only, right? Then header will be only loaded, and just a 1 KB or 2 KB of data, nothing more than this, right? So only the specific data is downloaded from the server, right? So it simplify the structure, like in term of benefits, it simplifies the structure. Like we are not depending upon the module level, right? Increase the flexibility, right? We are directly importing, right? Better performance, eliminating the extra modules. So let's assume previously the header, like we have a header and we have a footer, we have other component also in the same page, same module. Now all the module, when module is going to load, then all the component is going to be fetched from the server. Now when we have an only header composed separately, right, then we are only fetching this header from the server. We are not fetching the footer component and the other component from the server, right? So it's improving the performance. In term of pros, faster setup and easier to learn, encourage modular design. So in the ng module we are defining the imports inside the, like we have an egg bundle, right? but we can also use this approach. We can use the imports inside the standalone components. We can define the providers inside the standalone component, right? In term of course compatibility issue with older versions. So yeah, like Angular 18 is come with the stable versions, right? So like before Angular 18, in Angular 15 we can use the standalone true if we want to create the standalone component, right? And before the Angular 15 we are not able to create the standalone component, right? So these are the issues we have. Are required careful use for optimal architecture. So make sure like if you are using the standalone component, then the dependencies are separately assigned, right? If we have a specific requirement, then we are only adding the specific module inside the component. Unnecessary modules should not be imported entirely inside the standalone component. Anyone have any question? Okay, I'm taking it as a no. Moving to next. Next is the component level optimization. So in the component level optimization, as an developer, right, we are every day showing the list, creating the forms, handling the async operations, right? In Angular, right, we are creating the observables, right? Subscribe to the observables to display the data in the view. So how can we improve that, right? In the component level. So first is that we can use the track Y. Track Y minimize the ROM re-renders. So if we use the track Y, where we, let's assume we have a list where the list data is updating frequently, right? So like if a user updating the and indexing data, right? Then why should we re-render the whole list when we are updating only the specific indexing data? It means we need to only update the specific indexing data, right? Then we can use the track Y that will make sure that if any specific indexing data is updated, we need to re-render the specific indexing data instead of the whole list, right? So let's assume we have now hundreds of like we have now hundreds of data inside the array, right? Now you can see if we are not using track Y, then if we are updating any single data, then the hundreds of the DOM elements going to be updated. Okay, but now if we are using track Y, then only the specific index like element is going to update it, right? So it's like we already updating one in term of 100, right? So it's going to optimize the component level. Now in term of expensive computations, so let's assume we have performed some expensive computations, right? And we need to perform it on multiple places. So how can we handle that one? Instead of performing to the multiple places, we should use the RAGS observables that emit the data and we can subscribe to them. So we can use the share reply here, where share reply help us to optimize the application on component level, right? In term of the async pipe, we can use the async pipe that help us to subscribe and unscribe to the observable automatically. So as soon as the instance of the component is created, like as when we are using the async pipe inside the DOM in HTML, right? So what happen? It will subscribe to the observable itself, and as soon as the instance is destroyed, like we are going to another component, right? Then when we are going to another component, it will unsubscribe to itself. We don't need to write the logic, right? We don't need to go to create the and one variable, then we need to assigning the observable to the variable, and then we are when we ng on destroy is going to execute, then we are like unsubscribe to them. We don't need to do all of these things, right? We just need to use async pipe. It will handle all the operations itself, right? Scenario either for handling large. So if we are using a track Y, that is if we have a large data, that's ideal for using for large data. In term of pros, reduce the DOM updates for better performance. So if you can simply like think like if we have a single data that's going to update, right? And it's only updating in the DOM, right? Or a hundreds of we have hundreds of data, and hundreds of DOM is going to 100 element of DOM is going to be re-rendered, right? So re-rendering the hundreds element or are rendering the one element, right? So it's simple. We can easily understand. We need to use the track Y. We should use it track Y in simple terms, right? In term of cones require answer logic for track Y. So it like we need to define one function that returning the ID, the specific thing we can identify that it should not be going to the change when the list is going to update, right? So like every like we have a list, right? Then we can create the some type of unique id, right? So it will like track that we have a specific index. Now add complexity for managing RAG streams. So yeah, if you are using the RAGS stream for like optimization to make sure like when you are using that, what is the result of the RHS observable, right? If you are using the share reply, it will emit the data. But if you are using switch map filters, right, then they have a different data as they define, right? So make sure if you are using these observables, so you have enough proper knowledge and proper understanding, proper edge case where you are using, right? Anyone have any question? Okay. One more thing. You can use the signals in the Angular 18 or in the Angular 19. Signals are introduced. So signals is also the one of the best way to like improve the performance. So they are async itself. We don't need to async pipe. They will emit the data itself whenever the new data is updated, right? So like we don't need to like if we are using the on-put chain detection with the signals, right? So signals will update the UI itself. We don't need to tell the Angular go and detect the changes, right? So this is the one more plus point. Next is the how can we improve the asynchronous operations. So like in the day to day, like whenever we have a search box, right? And when you are inputting something, right? So we should make sure that if we are calling the API on input, it should not be called on every keystroke, right? Why should we call the API on every keystroke? It increase the server load, right? Right. So we should make sure that if we are using the like search, we are doing the search, then we should use the debounce or throttle, right? Debounce is the one for the search one, or throttle is for the like disabling the button. So here you can see in the example we are using the debounce time, then every keystroke when the form value is going to change, right? So we are debouncing the time to the 300 milliseconds. So after the specific period time, we are calling the API, right? We are using the switch map also. So switch map is the RHS observable that cancel the previous API, right? And call the again new API, right? So it will also help us to improve the performance, right? If we are using the take until, right, then take until is allow us to unsubscribe into the observable, right? If we have a specific condition after like we are getting the data 10 times, after taking the data 10 times we are unsubscribing time, so we can use take 10, right? But take until is here, so we can use the take until, and then we emit that now the observable is completed. Now we don't need the data, then unsubscribe to them, right? So we can use that for unsubscribing to the observables, right? Ideal scenario, if we search think about the switch code, switch map and device time, this is for the search boxes, right? We can if you like using the forms, right? In the day to day we are using forms and we are submitting the forms, right? So we should use the total in buttons, right? After clicking on the button we should disable the buttons and show the loaders. So user will be not able to click the button again, so user will not able to call the API again with the same data, like it's unnecessary increasing load of the server, right? So the what is the pros? It prevent redundant API call, as I explained, and reducing the server load. So if we are not calling the API multiple times, right? So server load is going to be reduced. Improve app responsiveness efficiency. So like you are not calling the whole code at every time, right? You are restricting them for a specific period of time, right? After that you are calling the API, right? So it improve the efficiency and responsiveness. In term of cons, like same if you are using RHS observables to make sure that what is the scenario and what is the result of the RHS observable, and what if let's assume if term of switch map. If I talk about switch map, right? If you are not handling the empty string condition, let's assume user entering something and then instantly he cleared the field. Now switch map will call the API and it's throw the error. In that case you need to handle the switch map by explicitly, right? So these are the points we need to like make sure like when are we using the any RHS operator, right? require familiarity with reactive programming. So yeah, we need to be like familiar. We need to know like we should have an experience like how switch map behavior behave, how do bounce time behave, how take until behave, how other off variable of RHS operator, other operators is behaving, right? Okay, so any question, anyone? Okay, I'm taking it as a no. Moving to the next. So the most important part, the web core vitals and why they matter. So even you are a Angular developer or React developer, Java developer, or Svelte developer or a Vue.js developer, web core vitals matter every place. And you know like if your application web core vitals are like lagging, right, not matching the key metrics, that means your application performance is like your application performance is not good. You need to improve the you need to follow the approaches to splitting the code, modulize the code, right? You need to follow this approach to improve the performance, right? You need to optimize the APIs. You need to reduce the unnecessary blocking of the resource, right? You need to like multiple things you need to do, right? So for optimizing the application, the first is the FCP. Let me come here so we will be understand like what is the FCP and how can I check in real time, right? So FCP matters the measured time to render the first visual content. So as soon as the first byte of the app like our code is going to be rendered in the DOM, this is the time FCP is here, right? So for the if we have a 1.8 second or less than 1.8 second of any application, if we have a first content paint is less than 1.8 second, it means our application is really well, and others key metrics is also going to be good. But if the FCP is lagging, that means others will also lag, right? So if we go in the demo here, so if I tell you, right, so I'm just creating this and then handling. So you can go like in browser and application. You can be having a performance tab. So let me show you why simply, right. So you can go press the Control Shift I, and then the you will be presented with this header, and then you can select the performance. Then you can here select the record and reload. Then it will provide you the matrix. What is the matrix of your application, right? So let me reload that one, right? And I'm going to the here, then here, and then it's just 3 seconds. Now I'm here. Okay. So if we look into that, so you can see here's in FCP, and for that application we have a last code, right? So for FCP is the 1.5936 millisecond. It's in millisecond, right? So if any applications have a FCP less than 1.8 second, it means our other metrics are also going to be good, right? So we can simply look that you can see LCP is also be green, INP is also green, CLS is also zero, right? There is no any cumulative shift, right? So by FCP we can simply measure that our application performing well or not, right? So how can we improve the FCP in like we can minimize the render blocking resource, optimize server response. If we are using API, then API should respond within the milliseconds, right? Compress and prioritize the critical access to make sure if you are like loading some content by library, you are using like sometimes we use the third party libraries, right? So we should prioritize the things, right? So after getting the like if you have a specific requirement, like using a Google login, right, and you are using the GSI library to load the Google login button, right, then you can prioritize key after DOM. After fully rendering the template, we are going to load the like library, then user login button is going to be load here, right? So this is the one of the example like how can we improve the FCP, right? Or like we have a styles also, right? We can add the different async in the our link tag, right? A script tag that will allow us to load the script after the whole HTML content is going to be rendered, right? or like after, for like if we using async, then it means like we are loading the content as soon as the it's downloaded, right, from the service, like from the server. So we can use this async defer, or like load the specific library after a time, so it will improve the fcp. Now if I move to the next, next is the lcp, largest contentful paint. So you can go in your application and simply see like what is the largest contentful paint, right? If you click on that, it will show you the largest contentful paint for this application is the header, and how much time it takes. It takes the 159.336 millisecond. So if it's less than the 2.5, if it's less than 2.5, it means our application is really well performing. And like if we have a small things, we can improve, right? Otherwise it's good, right? So how can we improve the lcp? Optimize image and videos. So basically, like it's a very small example here, but like in the real example, we have a large content, like when a header, then we have a youtube videos, we have an images, we have a list of the content, like we have a list of the content, right? We are displaying, like you can see we are displaying the users here, so maybe we can displaying the food list here, right? So all these things, we if we optimize the images, right, so the images will load, images will be downloaded within the seconds, within the milliseconds, right? So it improve the lcp, right? We can use the cdn to cache and improve the performance, right? So why caching will be created for the images and the like if I go here in the demo, right, and let me go to the network tab, right, let me clearing that one. So in the front end side, the cache is created simply, right? If I go to the dashboard, you can see the chunk is loaded on a specific path, on a specific route, right? So it's we can if I go again back on the users, then we are not calling any api, right? You can see no any component is loaded here, right? So we are optimizing it, right? This cache is created by the browser, but for the if we have we can use the cdn also. So cdn provide the cache. So like if we are using server side rendering, then cache is already get on the server side, then we only get the cache here. We don't need to download the whole script, whole like file from the server, right? Reduce server response times, like if we can optimize the api, that's also good, right? In terms of CLS, so CLS is the depend upon the cumulative layout shift. So if I say in the cumulative layout shift, so you can see we have a header here, we have a card here, like we if we have a footer here or we have a list, and if we are getting the list first, then we are getting the header data, then we are getting the footer data, right? Now we are rendering the list first, then we are rendering the header, then we are rendering the footer. Now the you can think simply the layout is shifting. First we have a list, then we have a header in, or we are putting the header on the top, then we are adding the footer on the bottom, right? So now the as the cumulative lift cumulative layout shift is changed, right? It should be not greater than the 0.1 second. So every application should make sure that the cumulative layout shift should be less than the 0.1 second. It means like 100 millisecond, right? How can we improve? So make sure like we can we can specify dimension for images embedded, and make sure if you are inserting the content, as I explained, if you are inserting the header on the top after after getting the list data, right, that it going to be comes in the cls. If we want the cls to be 0, then we should first render the header, then list, then footer, right? So we can, why these metrics, we can find out how our application is performing and where we are lagging. And it provide us basically where we need to improve ourselves. So if you go to the in the we have a lighthouse, you can run the lighthouse, and lighthouse provide you na details like what is the things are going on, right? If I run the lighthouse for that one, that it's not better, it will throw the basically wrong report because it's in local, right? And we are not using the any real time. So like you can see here like it's saying the first country 9.6 seconds, so it's providing the wrong data basically. But if you go here in the down, You can see last contentful paint. What is the things are happening here? You can see it's providing the images also, so you can look into that. Okay, this is the last contentful paint here, right? If you go, you can see like if we are using some library, right, it will provide you the reduced JavaScript execution time. So it will provide you what's really going. So you can see this is Chrome extension. We can simply remove that one. And you can see we are not doing anything. It's good for us. It's loading the only the dashboard file on requirement, right? But if we are using the some libraries, then libraries will comes inside this reduced JavaScript execution time, right? So here we can look into the all the points where we are lagging. We can how we can improve, right? Anyone have any question related to the web providers? Okay, I'm taking it as a no. And now moving to the um, next part is okay. Okay, so what is the last one? Last one is the INP. So I forget to show you. Let me just go to the performance one. Yeah, here. So you can see here INP is 17 millisecond. So what is the INP stand here? So INP is the user interaction. So if I'm clicking on these buttons, right, then the content is changing, right? So is it blocked? Like if we are like if we are blocking this clicking on the button, no, we are not blocking, right? So this comes in the INP, right? So if the INP is less than the 200 millisecond, like user is able to scroll to the our application, user is able to the change the content, user is able to the navigate to one page to another page within the 200 millisecond, right? Then it's come in the INP. And how can we improve? So reduce the main thread work, right? So we should make sure like we can use these service workers to reduce the main thread work. Service workers the another topic. So we will come with the another session for these service workers, but we can use these service workers that help us to reduce the main thread work. And we can optimize the JavaScript execution. So we should not call the unnecessary logic on clicking on the button, right? If we have some we need to call, then we can then first we need to click the button, and then we should perform the operation after landing on any page after scrolling, right? Now reduce interaction blocking. So if a user interacting with the application, that it should not be blocked, right? So we can follow these improvement tips. Why they are important? So you can see web providers are critical for user satisfaction. If the FCP is less than the 1.8 millisecond, right? In the real world, user will not stay or retain our application. User will close the application or browser, right? And will go to the browse the another application. So if we want like user will stay or retain our application, then we should follow the web providers metrics, right? Directly impact conversion rate and retention. So as I explaining, users should retain our if we want and users should retain our application, then we should follow the web providers metrics. Provide actionable metric to improve overall web experience. So as it's providing the details like where we are lagging or what we need to improve, right? Like if the FCP is more than 1.8, then it will provide you the details. Here is the you need to improve, right? You can reduce the you can load the another library after loading the content, right? So it will help us to like improve the app basically web experience or user retention, right? So anyone have any question anyone? Okay, I'm taking it as a no. So now next is the demo part. I would like to invite the Arjun. So Arjun, your stage yours now.
Okay, thank you, Piers. So let me just share my screen. Okay, so is my screen visible?
Yeah, Arjun.
Okay, so hello everyone. So in today's demo, we're gonna cover some powerful techniques to make our Angular application faster and more efficient and more scalable. So let me just show you the demo part. I already created the application to showing the some functionality. Let me just serve it. Okay, so this application generated with the Angular 19. So every functionality or the function we are going to use or the of the Angular 19. Okay, so first let's start it with the lazy loading of modules and components. And basically you can load lazily anything, like you can also load the images and the component or the files also. So I'm gonna show you that how our application work when we are not loading our components or the modules lazily, and how it's work when we loading our applications using the lazy lazy loading techniques. So in the route files here you can see I commented the code for the lazy loading, but right now our application loading the components without lazy loading techniques. So let me just show you how it's working right now. So right now we are on the dashboard page, and if I refresh it, so here you can see there are multiple chunks are loaded just to browse it there, and there are 4 components which is loaded on navigating to the dashboard page. First component is dashboard. Yeah, we are on the dashboard page, so it's necessary. And second is loading spinner. Basically it's for the loader, but right now on the dashboard we are not using the loader, but it's also loaded. And the third is the users component. Basically user component for the another tab which we are gonna navigate after this, but it's also loaded. And right now on the dashboard page we don't need the users component, but it's also loaded. And fourth one is a app component. Yeah, it's necessary. Basically every component is rendering in the app component. So right now there is only 2 components which are needed, the app component and the dashboard component. But the loader component and the user components also loaded, and we don't need them right here. So yeah, it's make our application slow. Right now I'm gonna show you after implementing the lazy loading how our application gonna work. So I'm just uncommenting the lazy loading code and commenting the default functionality. Okay, so when we are working on the lazy loading, we don't need to import the component specifically, or and we are using the load components, and when we user navigate to the specific path or the specific URL, only then the specific component is loaded and imported. So I'm gonna comment the import part also and just save it. Okay. Okay, so here you can see I uncommented the lazy loading code, and right now we are dealing with the lazy loading technique. And here you can see only 2 components are loaded on the first hit. So first one is the app component. Basically, I already told you that every component is in a app component, so it's mandatory or necessary. And second one is the dashboard. Yeah, right now we are dealing with the dashboard or on the dashboard path, so it's also loaded. Okay, let me just clear the network. And if I navigate to the users, okay, so here you can see after navigating to the users, the 2 components also loaded. The first one is loader. Loader is for this component, and second one is users component. So basically when we navigate to the users components, only then the chunks related to this component is loaded, otherwise it's not loaded. And if I go back to the dashboard and come back to the users, it's not loaded again. Basically all the chunks are saved in the cache, and only first time when we navigate or dealing with the new data, it's loaded from the server, otherwise everything is saved in the cache. Okay, so any doubt or any query on the lazy loading? Okay, I consider it as a row. No. And second topic, I'm gonna show you the standalone component. So let me show you before the standalone component how our application used to be. Okay, I right now I already told you that we are dealing with the Angular 19. So a standalone component basically introduced in the Angular 16, and I'm dealing with the 19. So it's by default every component is lazy load. But before that, I already created the application with Angular 16. Let me just show you the code of the. Okay, so this is a basically code when we are not working with the standalone component. So every component is declared in the app module.ts file. So if you initialize or generate any component in the app module, so every component will be configured here. But in the standalone one, we are not depending on any modules. Every component is independent, like the dashboard component. Okay, so like the user component. So every dependency and module related to the user module are imported within the user's component. There is no module file like in the Angular 16. So we are not depending on the any modular file or any modules. So basically it's make our code more structure and our components not reliable to the another components or any modules. Okay, so after that I'm gonna show the some component level optimization. So like okay, like Piyush already show you in the PPT part, we are using the track by. So basically track by is for the Angular 16 or the previous version, but after the 17 version, the we are dealing with the Angular built-in control flow. So now syntax is the track. So we are using the track to track the list. Basically by using the track, we are not re-rendering our whole list on the changes of any list element removal or the adding when we are adding any users to the filtered users. So only the specific user will be impacted, and whole application will not be rendered again. So
Sorry to interrupt, Arjun. We are already past the time scheduled. So can you just confirm how much more time would you need?
okay, it will take only 3 to 4 minutes. Yeah.
Okay, okay. Please wrap it up soon. Okay.
Okay, no problem. Okay, so next topic is the on push change detection cycle. Okay. Okay, so in the application you are seeing the loader is loading, and in the TS file here you can see we are we are initialize our data in the filter user and on the initializing time, and yeah, and in the template here you can see the loop are also on the filter user. So anyone can know why it's not working. We are initialize the data and looping on that. Okay, so if no, let me just clear it why it's not working. Basically, we are here using the change detection cycle. Basically, Angular by default checks the changes, basically detect the changes on the every check. And right now, if we are added the change detection strategy, so then it stop its by default functionality and only detects the changes if we are using the detect changes. Like we are dealing with the async operation, and once it's initialized during the initialized time, it's not initialized after the 1 second the data is assigned in the this user. So Angular is not detecting the changes. So for detecting these changing, we are gonna use the change detect on push strategy. Let me just uncomment it. And so
So, like as I explaining in the previously, so if you have a dependency where we one API depend on another and another API depend on the another API, right? And instead of the rendering the like every time template, we should render the template only one time. We should run the code at one time, right? So we can use the on push at that time that then and we can tell the Angular now. Just go back to the code, Arjun. So we can
yes.
use the change detector dot detect changes that will tell the Angular now we have no data and update the view. So it will like it will like re-render the template and then update the view. When we are with the, now we have a control, right? And we are telling the Angular, okay. Yeah, you can continue.
Okay, so last topic is the debouncing. So basically, sometimes we need to control the how often a user types a letter. So every time a user types a letter, it can overload the servers, and so debouncing help to delay the function execution until the user stop typing. So let me just show you how it's working. So when we are not using the debouncing, you just see the console how it's gonna work. Okay, so here you can see on every type of the key, the function, the function, yeah, the pipe, the subscribes method is called on the every key press. So we don't want to hit the server on the every key press. So we are using the debouncing strategy. So if I uncommented and show you, so here you can see if I click a key in a multiple time speedily, it only call the server one type or execute a function only a single time. And for this I set it the 60 milliseconds. So yeah, this can reduce the load time on the server. So any doubt or any query related to the PPT or the demo from anyone?
So these
Arjun, can
are,
you explain?
yeah, Shanavas,
Piyush,
go on.
please go ahead.
Yes, Anwar.
So, what is the real life use case of debounce? Like, suppose why we use a debounce? Suppose some user type his name, like my name is this, and then we call the API after 5 seconds, we can say. So, when it comes in the picture, like how debounce help us?
Okay, so basically for here, you can treat this search user search input as a Google search. And if you try to search like the my protein or the converter, time converter or the daily task or anything, and you type the like daily task without debouncing. Let me just show you without debouncing.
Okay, got it. So, yeah, you have presented the real scenario. Okay,
Yeah,
continue.
without debouncing, it will
Yep.
hit the server
Multiple times.
at many time you type the key. And with debouncing, you can set it like a particular time that after this time only call the server again. It's
Okay.
reduce the server hits basically.
Okay. Nice. Thank you.
Okay. Anyone else? Any doubt? Any query?
No, Arjun.
Okay. So in the last, so these are the basic, optimization steps you can follow in your day-to-day work, right? So like every day, like we can use if we are like creating this search box and we are calling the API, we can use the debounce, right? We can use the total to restricting the button to again call, right? We can split
Right.
the code. So these are the day-to-day work, and hopefully you all like get the knowledge, uh, such content. So please provide the feedback, and so we will be able to understand how we are, and like where we are lacking and where we improve ourselves. So please provide the constructive feedback. Thank you.
Thank you, Piyush. Thank you, Arjun, for an amazing session. And thank you, everyone, for joining the session.
Great session,
Thank
Arjun.
you.
Okay.
Thank you.
Thank you,
Thank you,
everyone.
everyone.
Nice
Thank
session.
you.
Thank you, everyone.